All right, for this video, we're going to look at the second part of section 10.7, which is dealing with compound interest. Now, it's going to actually have some similarities to part one as far as the formula goes, but there's going to be a little bit more that we're going to look to put in our formula. Okay, now you can see I've got the compound interest formula right here given to you guys. We got A is equal to P times 1 plus R over N is equal to NT, or I'm sorry, to the NT power. Now, a lot of those letters are going to be the exact same that we just saw on 10.7 part 1. The P is still going to stand for the principal amount, how much we start with. R is still going to be a rate, a percentage that we'll convert to a decimal. And T is still going to stand for time. Okay, the big difference, and you can see it's in two spots right here, is N. Okay, we're talking about compound interest. So the N is going to stand for how many times your money has been compounded to gain interest on that. Okay, so that's going to be what the big add-on is. Okay, now for the N value, there's a couple different things that it could be. You've probably heard the terms compounded annually, quarterly, monthly, maybe semi-annually, things like that. That's how many times per year the interest is collected on it. Okay, so if it's compounded annually, then our N value is just going to be 1. If you see it's quarterly, N is equal to 4. And if it's monthly, your N is equal to 12. Okay, now if it was daily, it would be 365. If it was semi-annually, it'd be 2. If it was weekly, it'd be 52. Whatever it may be, something along those lines. It's just how many times per year are we compounding interest. Okay, so what we're going to look to do is the same kind of process as 10.7 part 1. Go through, identify our variables, figure out the big part is the N value, and then work to try to solve. Okay, and so you can see we've got 4 different types where we're missing 4 different variables throughout. Okay, so as we read through this first one, we invest $4,500 in a savings account that pays 3% annual interest compounded monthly. How much money will be in the account after 5 years? Okay, so reading through, you can see the first number I have, the $4,500, that's my principal amount. That's what I want to start this account with. Okay, my percentage looks like it's a 3% annual interest, so I've got it as 3%, which really is 0.03 for us. Now, this is compounded monthly. So you can see by our little chart right here, that means that N is equal to 12. Okay, and then our final number, our variable, is T is equal to 5 because we're talking about 5 years. Okay, from here, we're looking for A. Let's just plug it all in. My principal amount is $4,500 times 1 plus the rate, which is 0.03, divided by the N, which is 12, all to the NT power. So that's going to be 12 times 5. Okay, now as far as simplifying goes, okay, I've got a lot of the work here. You're going to be able to combine this into probably a couple steps, but the first thing is I would divide your rate by N, so my 0.03 by 12 gives me 0.0025. And then I went ahead and multiplied my N times T and got 12 times 5. Okay, from there, I want to combine, make that 1.0025 because I'm adding 1 plus that. Okay. Now, kind of like we did on the last section, I would take care of this part of the problem first. Take that 1.0025 all to the 60th power first before you do anything else. And then from there, we can multiply it by our 4,500. Okay, and then we'll just simplify. Okay, and you can see I've got a dollar sign there. It comes out to about 5,220. Okay, so the big takeaways on that is make sure we divide our R by N. We multiply N times T, and then look to multiply this part here first. Okay, and so that's the same kind of process that we're going to see on these other type of problems here as well. Okay, and now the second one, how much money must be invested in a savings account that pays 3% annual interest, compounded quarterly, if you want to have $7,000 after 8 years. Now, again, I know that there's a lot of information. Just to go through, list out A, P, R, N, and T, see what we have, see what we need to still find. And for this one, the first thing, A is our 7,000. That's what we want to have after the 8 years, which is our T, our time. Okay, now it's compounding quarterly this time, which means that we're looking at N being equal to 4, and it's a 3% interest rate again, so that's going to be 0.03. So what we're missing is the principal amount. How much are we going to have in that account to start? Okay, so let's fill this in. Now we know A, so 7,000 is equal to P, our principal, which we don't know, times 1 plus 0.03, our rate, divided by our N, 4, all to the 4 times 8, the N times T power. Okay, and again, kind of working through, we want to simplify this right part here first. So 0.03 divided by 4 gives me 0.0075. I'm going to add that to 1 to get 1.0075. Okay, and you can see I've got an exponent of 32 because I multiplied my 4 and 8. Now, just like I did on this previous one, I'm going to go ahead and multiply that out. 1.0075 all to the 32nd power on your calculator, which we should get right about 1.27. Okay, so we're left with 7,000 being equal to P times 1.27. Okay, so from there I just divide. I get about 5,511 and 81. Okay, now yours might be a little bit different just because of the way you rounded, but as long as it's somewhere in that ballpark, then I'm okay. Okay, all right. Next one, and again, we're missing a different value here. You want to have $20,000 10 years from now. You currently have $16,000. What annual interest rate, compounded monthly, is necessary for you to reach your goal? Again, we're labeling. What do we have? We want to have $20,000. So that's going to be our amount A that we're trying to get to. 10 years from now, so our time is going to be T. We currently have $16,000. That's going to be our principal amount. That's what we want to start this account with. We're compounded monthly, so that's N is equal to 12. Okay, the issue here is that we're trying to find the rate. Okay, so let's go through. Let's plug everything in. 20,000 is going to be equal to 16,000 times 1 plus R, which we don't know, over N, which is 12, all to the 12 times 10 power. Now, I've done two things here at once here. I want to go ahead and get rid of this number that's in front. So I'm going to go ahead and divide by 16,000 on both sides. So 20,000 divided by 16,000, get 1.25 over here. Now, I've also multiplied my 120, or 12 times 10 and get 120. Now, similar to what we saw in the last section, we need to get rid of this exponent. So what we'll look to do then is take both sides to the 1 over 120 power. Okay, so 1.25 to the 1 over 120, we get a real small number, about 1.002. And now, from there, that leaves us with just this 1 plus R over 12. Now, as we simplify, we'll subtract the 1. I'm going to get 0.002 is equal to R over 12. Okay, and then I've also gone ahead and multiplied both sides by 12 to try to get R all by itself. Okay, and we get a 0.024. And again, like we saw on the last section, we don't want to leave our rate like that. Move it 2 decimal places, and we'll get our rate of being 2.4%. Okay. All right, now this last one's going to probably be a little bit tougher. Okay, anytime you're trying to find the time, it's probably going to be the toughest type of problem you have. So we should say want to have, I'm sorry for the bad grammar on that, 5,000 that you would like to see grow to 8,000 in an account with annual interest rate of 5% compounding quarterly. How long will it take for your money to reach 8,000? Okay, so we want to get to 8,000, so that's going to be our amount A. Our principal is how much we have now, which is 5,000. The rate is 5%, so we change that to 0.05, and then it's compounded quarterly, so that's going to be 4. Okay, so as I plug everything in, it's 8,000 is equal to 5,000 times 1 plus 0.05 divided by 4 to the 4t. Okay, that's NT, so 4t. Now, first step, let's get rid of that 5,000 that's out in front. Okay, so 8,000 divided by 5,000 is going to give me 1.6 on my left side. Now, over here on the right side, I went ahead and took 0.05 divided by 4 to get 0.0125. And I still have that 4t that's left up there. Okay, so I've got 1.6 is equal to 1.0125 all to the 4t. Now, what this is a change of base problem. So what we'll do is we'll take our exponent, which is in this case 4t, is equal to the log of the number that's all by itself, 1.6, divided by the log of our base, which is 1.0125. Okay, now multiplying that out, or I should say dividing that out, we get 37.83. Okay, so what it'll be is 4t is equal to then 37.83. And just to solve for t, we'll go ahead and divide by 4. So we get t is equal to about 9.46 years. So a little over, almost 9.5 years it's going to take to get that. Okay, so again, just like the last section, guys, make sure we go through, identify what you have, A, P, R, N, and T. The big difference is the N value. Remember, right up here, we can see it. N is annually. For N is 1 if it's annually. Quarterly is N is 4. Monthly, N is 12. Okay.